and then try to get back to Carol's. So I wanted to just give a brief report about a workshop that was held last October in Pittsburgh on autonomy for NASA science missions. Several people in the room were there. I'll tell you a little bit more about it. Naturally, the part I was a part of was small bodies, but this will not convey what the workshop was like because there were a few people who do science or engineering relating to spacecraft missions. There were people who do like autonomy, so people who work with self-driving cars, people involved with trying to figure out how to make the UAV delivery drones for Amazon autonomous, things like that. So what I'm going to give you is just a very brief thing. This is a more official thing, so I'll skip over some of the slides. What I'm really looking for is, bottom line, ideas for what are the things we need in the way of autonomy to help our community. And of course, we all know that every spacecraft that we fly beyond low Earth orbit, at least in recent years, has some autonomy involved. We saw Hayabusa 2 homing in on the beacon. OSIRIS-REx sampling obviously is going to be autonomous. This was a workshop not just about small bodies, not just about planetary science, but all of the NASA throughout the Science Mission Directorate, and ultimately the recommendations will go to Thomas Zurbuchen. The small body, DRM, there are 3 names on here who are people who are in the room, myself, Andy Rifkin, Julie was able to call in. There are some other people on here that you will know. There are some other people who are involved with this who are more, people working on autonomy. And I should mention that the leaders on this part were myself and Ethan Nessinis, who is the principal technologist at JPL. I believe that's his title. So we're trying to mix the 2 groups. Just a reminder for scope for small body stuff, we pointed out that small bodies is more than just science. It also involves planetary defense, resource utilization. We said, let's leave human exploration out of this because you don't need the autonomy so much. For what we were doing, we talked about there are all sorts of different platforms, but what we're trying to do is figure out what scientists would like to see in the near-term and long-term future. And a part of it, which this group is not going to be so much able to address, is what engineers would like to know from scientists and what industrial partners would like to know. And talked about both what current activities enable for missions that aren't things that aren't being done yet, what incremental things could be done, and what would be revolutionary. Science drivers, just to know what we ended up talking about, Pluto and Ceres were ocean worlds were being talked about, so we left those out. We focused on smaller bodies. Maybe this is partly because Andy and I were in the room and we are more part of the inner solar system small bodies community. But in particular, we thought that the things that were interesting for small bodies nobody else would touch are the things where there's enough gravity to be a problem, where there's enough gravity that you have to pay attention to it, but not enough that you can anchor, not enough that you can orbit comfortably and go into a safe mode easily. And we pointed out that there is a diversity, and part of what we're trying to do is, can we use autonomy to address the diversity that we have? The things we came up with that we concluded were most widely applicable are things like composition, identifying volatiles like water. Water is important everywhere in the solar system. Things that are involved with astrobiology or origins or resources. Any kind of compositional information is going to be valuable for these sorts of things. Geotechnical properties for many, many endeavors are going to be valuable. They aren't very well known. When you get to interacting with the surface, that's a big question. So let's see, I'm going to primarily skip through this. This was, what do we know? But, in terms of learning composition, what would be revolutionary would be to do multi-asteroid or multi-object, that could be comets, could be Trojans as well, flyby missions, particularly if you can use autonomy to reduce the operations cost, and particularly if you can do surface contact, which is very, very difficult to do. Isotopic ratios, except in the cases of comets that are outgassing, it's really hard to measure those sorts of things. And as I mentioned, geotechnical properties, we know so little about it. If we've got a 50-meter asteroid, is that a rubble pile? Rubble pile? Is it a rock? The closer we can get, the better our chances of figuring out what's going on. And if we can do things like seismic measurements or ground penetrating radar, which are easier to do from the surface, we're better off. So what would be enabling? Well, being able to do these interactions near the surface where it's a little bit on the dangerous side, on or below the surface. Dealing with the environment. This is particularly dynamic conditions on comets. Comets are the type example for this, where you'd love to have a spacecraft autonomous enough to know, oops, a plume just went off, I need to deal with that. Being able to access different destinations, particularly without having to have a lot of people in the loop to figure out where to go next. When we need to manipulate things, that is very hard to do if there's a human in the loop. I mentioned anchoring, sampling, particularly sampling in or near event on a comet, but already all sampling missions use some form of autonomy, and for resource utilization, you're going to need to dig in, you're going to need to anchor, things like that. And if you're going to extract things, you really, really want that to be done in an autonomous manner. And of course, planetary defense, well, you need to understand how to interact with something that's largely unknown. You want it to be something scalable. We want it to be something agile. So we need something that is a little bit more versatile than the one-offs that we have a habit of relying on. So the two kinds of missions we could envision that autonomy would deal with, the more realistic one, could we put a small sat mission to an near-Earth object and just put it in near-Earth orbit, and the ideal autonomy mission would be it finds where it's going to go, designs its trajectory, lands, accesses some target, samples, analyzes it, and of course, if you really want to dream about autonomy, then it sends the publication back. But so there's some key capabilities or technologies that are needed. Identification of asteroids or comets, how autonomous can that be? We all know that is currently, while there's a lot of computational power that goes into it, there's always humans in the loop. Mission design and navigation, cruise approach and safe landing, characterization of the properties of the objects when we get there, targeting. These are all things that, and then surface operations, these are things that we are doing, but just having heard the presentations about Hayabusa 2 and OSIRIS-REx, how difficult these things are to do, and wouldn't it be nice if we could do them autonomously with a smaller cost spacecraft with pick a target, let the spacecraft pick a target. Imagine what that could enable later down the road. And of course, a spacecraft that can monitor its own health and resources. So, the more longer-term dream, and so some of the things in here are the things we're recommending. Can we develop autonomy that can do some of these things in the relatively near future? Farther down the road, more futuristic, you could imagine having a centralized mother platform, if you will, that you kind of launch and forget. And when there's something interesting that comes along, there's a daughter satellite that goes out and explores it, whether it's Oumuamua, whether it's a near-Earth asteroid that comes by, whether it's a comet that comes in. The dream would be to have an autonomous system that you don't have to have many people in the loop saying, oh, okay, we'd like to go see this, what trajectory need to do. Could the autonomy people design something that could make a lot of these decisions for us? So that is the whirlwind tour, but the point here is to be thinking about autonomy. What are the things that could really make life easier for missions that aren't these purely autonomous missions, you know, it's going to be steps, but what are the steps we need to take? And so I'd be happy to take questions or suggestions. Andy or Julie would be happy to take suggestions as well. Andy, let me give the mic. Okay.
Yeah, just to amplify what Tim said, certainly the idea in there was not that an autonomous vehicle would have to do all of these things by itself, but that, for instance, it could say, okay, the way that it's going to find a target is because it's constantly getting updates. You know, every day it's checking in with the NTC and going, oh, here's the capillary orbital elements of everything. And today, is there something I can get to today that I didn't think I could get to yesterday?
And it might send a message back and say, is this a good one?
Yeah.
And you say, yep.
Yeah, so this is not, it's not, you know, autonomy does not imply that it has to do everything by itself all the time.
Right. But you ask, could it do each of these things?
Yeah.
And could you pass the mic back to Meg and Paul?
I just want to comment a little bit about ways you can get here to autonomy. So at least for Mars orbiters, there's an effort to use machine learning, both using crowdsourced data sensitivity to make them, you know, the goal eventually is to have orbiters go, oh, that's the thing that the researchers want, image that, let's focus in on that because I'm passing by it. So one way you can do that is using training off of machine learning and using crowdsourced citizen science that. So both JPL is doing that, with a group we're also doing it, the Planet 4 project for seasonal fans, looking at having machine learning learn from our citizen science classification. So that's one way of actually finding more sort of crowdsourcing citizen science type things that have links to machine learning or machine learning algorithms that can then get you to the next step of having these things on data sets that have been validated both by research teams and other ways. So
Yeah.
I think that might be something a step towards getting there.
Right, particularly when you talk about things like identifying targets and figuring out what you want to do. Machine learning could be very valuable on that. Paul? And then Dan?
So Paul Abel, Master Johnson. So one of the things that I think, I don't know if you've actually alluded to maybe a little bit, but also the fact that we're getting the capability of having small assets working in coordination, and that can be autonomous. I don't know if that was just specifically mentioned, but something like that where you could have a suite of small sats or things, vehicles that would interrogate a target for a variety of reasons. I think that's something the level of autonomy, not only independent, but working in coordination.
Mm-hmm.
That's something that should be explored and considered. One of the things that we found out about HIDES 2 is how useful small autonomous vehicles, I'm thinking of like the Minerva rovers, are in interrogating a surface, especially for geotechnical and trying to understand what the surface is like, competitive implications for everything in terms of science, resource prospecting and things like that. And the other point I would just make real quick is that I still think there is some applications for autonomy even in human exploration missions because the astronauts, cosmonauts, technonauts, they are still going to have some downtime during sleep. And so you can still have autonomous vehicles do their thing, interrogate an asteroid while the crews on sleep chapter. So
that's absolutely true. But the diversity of things you could imagine doing was so large, we said, okay, that's one we're going to wall off for the moment. But you're correct.
Like 2 hours.
Yeah, we had a short period of time. So Dan.
Dan Adler. Just continuing with Paul's theme, I want to urge that this support human spaceflight in some capacity, particularly the research I've been supporting at TIS on low latency telepresence would make use of an autonomous vehicle or semi-autonomous vehicle during the cruise of the crew out to and then returning to Earth where the latency started getting smaller and smaller, so that you could start to do some semi-autonomous mode stuff where you say, well, I see a rocket you didn't see over there. Go over there and find some data on it and report back. You know, you get into a whole spectrum of possibilities. And certainly, as Paul says, during crew sleep, you can continue to extend that productivity.
Okay.
So good work. I would just urge more human spaceflight interface in the future.
Okay. Okay, one last question.
Okay, is there, and Sorry, I was
Oh, okay. Julie, so two last questions, but then that's it. Yeah.
there are a lot of software, software already available. There are significant investments by laboratories all over the world. But the next step is to use that software on missions. There is a big the challenge is to find the money or is it PI is ready to take the risk or so in other centers ready to make the investment into the validation and verification. DNV is really one big obstacle against the use of that software. So I think that would be really interesting to explore if mission, ongoing mission that should be the extended mission would infuse that software during the extended mission. Because the risk would be lower and the risk would already be there. And in most cases, it would be easy to implement the software into the current test path. And that would be advanced that way.
Oh, interesting. Yeah. Oh, okay. Sorry. Yeah, so the comment was that it might be possible to incorporate some of this into, for instance, extended missions, where it would not be part of the prime mission, so you would not have as much risk to the mission itself, but you would probably be able to upload the sorts of things you might need to know.
Mike Evans, Johnson, picking up on what Dan and Paul's talking. One of your last slides mentioned autonomous delivery of the sample to some other mothership, you said gateway. My question is do you envision any type of processing samples on these remote platforms, or would they just be gathered there and then relayed to Earth, like on a run-in or something?
You can imagine, the question is whether there's any processing of sample involved, imagine before returning it to a mothership, a gateway, whatever, and you can do as much as you want. And to me, that's actually a part of collecting it is there's going to be some sort of processing involved in collecting, I suspect, if you're going to try to do something autonomously.
The reason I ask is if there's any short-term requirements that could be developed now, it would help us as we're developing the capability.
Right. So short-term developments could help on things like gateway. Okay. So thank you. Let's move on to, do we have Carol on the phone?
Operator?
We're still awaiting Carol at this time.
Carol, could you dial star